All right, welcome back. So this is the exercise in lesson 3 we'll be going over right now. So you don't have it open, go ahead and open that lesson up. The first thing you run into is sort of the things we've learned in the past. So we're importing pandas as PD. We're taking the path of our data and we're showing it where the path of the data is, so where the actual data is stored. We're using the pandas function called read CSV to convert our CSV file into a data frame that our machine learning can use. And we're using this read CSV to do that. And we're going to read the file and we're going to put that into, so this read CSV reads it, and then converts it into a data frame and stores that into the home data frame. So now all the data about all the houses in Iowa are in the home data thing now. And then this last part's them just setting up their checks and hints and all that stuff. So real quick, I'm going to run this code. That's going to do all of that work of importing our data, putting it into a data frame, and setting up all the tutorial type stuff throughout the thing. While that's running, I'm going to go ahead and move down. The first thing we're going to do is we're going to specify a prediction target. So we're going to pull out the data from the table that we want to use as predictions. In this case, we're trying to predict the value of a house based on all of its information about the house. So our prediction for the Y is going to be is about the price of the houses. So here down in this code bubble, we're going to want to actually see what the columns are called, so we can see if we can figure out what it's called. It might not be called price. We may be called something else. So let's just look real quick. So we're going to do, our data is currently in the home data frame. So we're going to call home underscore data. And we're going to do just a dot columns command. No open close parentheses here. And we're going to run that. And that's just going to list out all the columns. We're going to find one that says something about price. So we're just going to keep zooming it. Here's one called sale price. The very bottom. Anything else? I don't think so. All right, so this is probably what we're looking for. So we want to pull that sale price data out. So we know it was something like that, but we need the exact name. So I'm just going to Control C. I'm going to copy that sale price. And now I'm going to pull that out of the data set. So to do that, if I'm pulling one column out, I can pull it down to what Pandas calls a series, which we would normally call a list. And that's this Y thing. So I'm going to say, okay, go to home data and pull out, that's the dot, sales price. So I'm going to Control V, sale price. So it's going to find the column called sales price in the home data frame and put that into the series Y, or the list called Y. All right, let's check that. Hey, we got it correct, yay. If we didn't get it correct, we wanted some help, we can come down here, take away that hashtag, and that would show us a hint. And that was letting us know that we need to do this up above. Okay. And then this one, we can take this one away and see the solution. And see it's called sale price. So the idea here is that it wasn't what we thought it was called, but we could figure out what it was by looking at the column headings. All right, that part's done. So now we need to create X. We need to define what are the features that we're going to take a look at in terms of predictive features for home value. And right now they've told us they want us to use this sort of abbreviated list. We could use all of them, but we're going to use just these here. All right, so first thing we need to do is create a list of feature names. So here, I'm going to come here, and it has to have a square bracket by it, just like all lists do, just like in JavaScript, I should say. And then up here, we're going to find the ones we want. So we want lot area, year built, first floor. Are these the right names? I think it did it already for us. Yeah, I think it typed them in correctly for us. Whoops. I double clicked on that, which means it allowed me to edit it. I'm just going to click on it, highlight it, Control C, Control V. And I'm going to separate these with commas and just put all of them in real quick. And I'm going to hope that they put them in. Oh, you know what we're going to need? We're going to probably need quotation marks to define them as a string and not a variable name. Let me check. Yes, we're going to need quotation marks on all of them as well. So also doing that now. So first floor, go back to those other two, Control C. I'm going to come down here and put in a quotation mark, V. You can do single quotes or double quotes. Up to you. Oh, I was hoping that would work. Yeah, it does work. If you highlight it and just hold Shift, you can put it, it puts it around both of them if something's highlighted. And then I'm just going to put in a comma here and just keep doing that. Come down here. Oh, I see why they use the single quotes, because it doesn't require a shift button, so it's one less button to press. That's interesting. Computer scientist people are always trying to find ways that have fewer keystrokes. So, comma, bedroom above ground. Oops, forgot to put it in. Do it that way. All right. I'm not 100% sure that I'm going to be allowed to have a mix between single and double quotes, but if it causes a problem, we'll figure it out later. All right, select data corresponding to features in the features names. Okay, so this is where we're going to actually go back to our home data table that has all the data in it, and we're going to just pull out just this list of columns that we want to pull out. To do that, the code up here, when we pulled out just one thing, we just do like a dot sale price, and that pulls one thing out. But we want to pull out several columns, so the way to do that is you're going to type out home data. That's the data frame where all the data currently is stored. And you're going to do an open square bracket, and you're going to feed this list into it. Control C, Control V. And that's going to put all of these things into that grab home data and grab one of each and put that all those columns of data into the data frame called X. All right, and then let's run that and see what we get. Hey, we got another correct. Yay. Now we're going to review our data. We want to be able to print the statistics from X. So down below here, at the statistics, like the describing information about it, is the describe one. So I'm going to go capital X for the name of my data frame that I made up here. So this is all of these columns in that one. I'm just going to do dot describe. Open close parentheses and run it. So I can look down here and see if things make sense. I got lot area, year bill, first floor square foot, full bath, bedroom above ground, total rooms above ground. I don't see anything too crazy on here. All right. So the average of the bedrooms above ground is about almost 3-bedroom houses, which seems about right. The baths are about 1.5 for a full bath. Okay, yeah, that looks pretty good. I don't see anything on there that looks too crazy. So let's do another one now. Instead of describe, we want to actually see the data in the table. So we'll just print out that first few rows. So capital X dot head, open close parentheses, and then I'm going to rerun this code bubble. It's going to reprint this one, and it's well, that was surprising. It didn't do the X describe. Okay. But it did do the X head, so I'm not sure why. Maybe it only shows one at a time if you have both like that. So let's just take a look. Lot areas, those look good. Those look like years. Those look like square footages. Second floor square footage. That's not surprising, but this must be just a first floor house. Full baths, great. Rooms above ground, rooms above ground. Okay, all reasonable. So in that process, we're just looking for something that pops and be like, oh, I think there's a problem here. Like this 0 at first popped. I was like, oh, that's a problem. But then I realized, oh, it's second floor square footage. It just means the first floor house. All right. So now we need to specify and fit the model. How are we doing on time? 10 minutes? We're good. Iowa model. So this is where we're going to actually from up here, we need this up here first. So we need to go get the model. So this model, you remember, is from sklearn.tree is where the models are. So sklearn, let me make sure I've got the syntax right. Yeah, it's all lowercase. Learn is the whole overall, like there's a whole ton of models in there. In that, there's a subcategory called tree models. So that's the .tree part. And from that sklearn.tree part, we're going to pull in the decision tree regressor. So I'm actually going to copy and paste it over from the old assignment so I don't make any mistakes. That did not work. Oh, it keeps messing with me. Let's see if that works. Yes, perfect. Decision tree regressor model from sklearn, the tree portion of that. And then my Iowa model, I'm going to do this same thing. So now I've imported in this sort of blank model. I'm going to take that blank model and give it a random start state or random state, random underscore state. I'm going to set it equal to 1. You can set to whatever number you want. I'm going to set mine to 3 because I don't care. That just means that every time it'll start at that same place, which means it'll give you the same results every time. If you don't define that, it'll start at a different place every time. It'll be a little bit, the model will give you different predictions depending on when you run the model. And we don't want that. All right. Next thing we're going to do here is fit the model. So we've got this sort of blank, unfit model with all the trees and branches sort of the same. What we're going to do is do a fit, which means the computer's going to go through and try and figure out better paths to take through the tree to get more accurate results. To do that, we've got to give it a few things. First, we're going to say, hey, we're using the Iowa model, so that's this thing up here. It's got that sort of blank decision tree in it right now. And we're going to do a dot fit on that model. And we're going to fit it using our capital X, all those features we put in there. And we're going to try to predict the Y's. And so it's going to use this data. It already knows what the value of each of these houses is. So it's going to use those houses to flow through the model, see if they do a good job predicting their actual correct values. If not, it's going to tweak the model around and keep retweaking it until it finds a way for the model to actually develop and create some good predictions. That's going to keep like tweaking. I think of it like, have you ever seen Plinko, where those like little balls bounce through the springs, the little or rods sticking out of the wall, and they bounce around them all over the place and they end up falling down into like different buckets at the bottom? Think of it like that, except the fitting allows the model to shift those little pins left or right to sort of adjust which way all the things go, so it can put them in the right, correct places every time. So that's kind of how I think of it, and that's this fitting process to make it work. Let's run our thing and see if we got it. Oh, we got it right. Yay for us. All right. Now we need to make some predictions. We want to see if our model is working well. So it says make using the X as the data. So we're going to do predictions equals, and we're going to predict, we're going to Iowa model. We're going to use our model now. This model has been fit. Underscore. Let me just go grab it from up here. So I'm making the typing mistakes. We're going to use our model that's been fit. So now all of the paths have been adjusted to create really good outcomes, we think. I'm going to do Control V, Iowa's model. And we're going to do dot predict. and we're going to predict X. So shift large X. So we're going to use all the data we just trained it with and have it predict those for us and store those predictions in a list called predictions. So it's going to have one prediction for every house in that list. All right, let's see if we got it right. Hey, correct. Notice that when it printed the prediction, it didn't print all of them and put this dot, dot, dot here in the middle. So it printed the first three and the last three in the list. All right. Oftentimes with machine learning, you're working with tens or hundreds of thousands of data points. So printing all of that on the screen would just take a long time and you have to scroll down forever to get there. So it usually doesn't do that. All right, this last part is thinking about the results. We're going to compare the top few predictions because this is the predictions it made without comparing them to the Y. It fit it by comparing them to the Y, right, to the actual values. But then we do the predict command. It says, hey, no, now just use the model to give us a prediction of what we think it's going to be. So now let's see how well we did. So we're going to do a head method. We're going to compare a few things. We're going to do let's do a few. Let's do X head. That'll show us the table. Let's make sure this works actually. Oh, kind of hard to read, isn't it? Oh wait, I think it needs that. Run it again. There we go. So that's the header. These are the first 5 houses in our list. And then below that, let's see if we can just do a Y head. And do the first 5 in that one. Let's see if it'll print below it or not. I think we had this problem before. I was doing the other one instead. And then let's do predictions. So that's where we have our prediction data dot head and see how those went. Oh, this just said all ahead. I don't know what that means. Boom. Whoops. Keep hitting enter. Play. Did I mistype it? Oh, of course, this is the one that doesn't have a cheater thing on there. Let me erase these two. Let me get rid of those, see if this helps. I'm trying to do something a little differently, but it's not working. I thought it would work fine, but it does not, I don't think. Okay, so this predictions thing we made up here when we ran this Iowa model.predict isn't a data frame anymore. It's some other kind of data type, and it doesn't have a head command on it. But we can just do the print the predictions. These are the first 3 of it. We can compare those first 3 of those predictions. So let's just do prediction dot. Let's just see if we can print them. So I'm going to use a print command and print some of the print predictions, and we're going to get that. And then maybe we're going to try this. Maybe we're going to print. I'll just say we can go find them. Let's just see if we can do this. Print Y. So these are the actual values. Okay, that'll work actually. So I printed Y. So this first list up here is the first 5 things and the last 5 things in the list. You can see there's almost 14,005 or 1,405, 6 whatever. There's that many houses in the list. And so the prices should be 208,500, 208,500, 181,500, 223,500. The last thing, 3 should be 266,500. Oh, look at our predictions. These are our predictions down here. They're exactly the same as our data. Does that mean that we did a perfect job modeling this data? Oof, I don't know. Let's figure out that later.